up until now, we focused on content-related surveys, but now let's briefly look at attitudes and beliefs. So we have one of the original developers of the Colorado Learning Attitudes About Science survey, and this is Kathy Perkins, and so she's going to be able to tell us about it. So this survey is sometimes referred to as the CLAS.
Okay, so the CLAS is an assessment tool that really measures students' perceptions around science. It's available in chemistry, physics, and biology, and it's designed to measure where their perceptions are along the scale of kind of novice-like perceptions around the science or expert-like perceptions around the science discipline. So what I mean by that is basically an expert would think about physics as being this coherent framework of concepts that describes nature, whereas a novice might think about physics as all these isolated pieces of information with no real connection to the real world. And an expert might think about, might approach solving problems using kind of these systematic concept-based strategies that are widely applicable, but a novice might think that problem solving in physics means finding the right formula or using a pattern matching approach to solving problems. So by using the CLAS, you can give it at the beginning of a course and at the end of the course, and you can not only kind of get a sense of where your population students are on that novice to expert-like scale, but you can also see how their perceptions shift over the duration of the course. And then you can reflect on that after you've given the course and think about my students, regressed in this aspect of their perceptions, or I only held them steady. How can I actually move them forward towards that expert-like, those expert-like perceptions around science or physics, through the way that through the strategies that I'm using in the class. The CLAS and other instruments like it have been used to measure students' perceptions in a whole slew of physics classes. And one of the most common outcomes is that we see students' perceptions around physics or around chemistry actually regress over the course of the term. And so that has really inspired a lot of research and new strategies around how can you, at least do no harm, hold students' perceptions constant, or actually advance some of students' perceptions around physics. So some faculty just look at the overall score that comes out of the CLAS, but other faculty really delve down into the individual statements. And so when we were first developing the chemistry survey, the chemistry faculty really liked looking at those individual statements and the distribution of students' responses, and it really provided a lot of insight into how their students were not seeing how chemistry was connected to the real world.
So Kathy mentioned that many students, after taking STEM courses, even reformed ones, can regress on many of the CLAS measures. So now we're going to show you an actual CLAS question and ask you to imagine the following scenario. So in this scenario, a colleague of yours has just taught an introductory course and given the CLAS. And after looking at their pre- and post-test results, they noticed that their students regressed in this area. So take a minute to think about the question and what practical advice you would give to help them improve their course. So in conclusion today, we've heard about a few different areas of research-based surveys that can help us better understand the impact of our instruction. We've looked a little bit at content surveys, both for lower and upper division courses, as well as surveys about attitudes and beliefs about STEM. We focused on content surveys mainly and also heard about how these surveys can be used practically and brought into instruction. And in those discussions, there were two major takeaways. The first is that broad results of these research-based surveys can really spur us on to talk to colleagues and to improve our instruction, but that also more specific survey items and how our students perform on them, such as maybe a very particular question about genetics, can help us understand semester by semester where we might target and improve our instruction.